Hi sir, today we are going to discuss about two topics. One is reverse of a string and another one is architecture of 8 through T7. First one we are going to discuss about reverse of a string. Reverse of a string. Here we are starting with starting with printing a macro. That one is macro name is S1 and leadx S1, and we are loading the effective address of S1 into dx and then move ah 09h and m in 21h. This is ended here, and then coming to model small dot data. In data we are declaring about two variables. S1 is a variable and S2 is a variable, and S1 in a variable we are declaring a string as enter a string, and S2 we are declaring a string of reverse of a string, and we are declaring three block 1. Block 1 is of a array with a size of 80, and block 2 is also an array with size of 80 and a line. And in coming to the code segment here, we are moving the at the rate data to ax and ax to dx, and we are printing s1. Here s1 is enter a string. Next leasi comma block 1. The block 1 address is stored in the si comma move cx comma 0. Cx is initialized to 0, and a printing line is printed here. Next one, it is a loop, and int si increment si. The si will be incremented, and move h comma 0 1 h. It is used for reading purpose, and increment cx also will be incremented, and al comma si. All the contents which are stored in the al will be moved to si. Compare al comma 13. This 13 is used whenever after the completion of a string we will get an enter button. If we get an enter button, this will compare with 13 and terminates it. Until it terminates, it will come here and loads the block to address into bx, and then come to next loop. Move si comma al. All the contents which are copied from al to si here, they will be copied to al again, and then al contents are copied to bx1, and the si will be decremented and bx will be incremented. Loop. Next, this will be looped until all the contents are copied to another. Printing s2. The s2 will be printed, which is the reverse of 1, and printing a line will be printed, and printing the block, the array also will be printed. This is the ending instructions. Here we see the output enter a string arjun, and the reverse of a string is nujra. Thank you. And the next one is the architecture of 8237. And coming to the parts, first we come to the timing and control. In timing and control, it has the following signals. The first signal is EOP, end of process, and it tells us the process has been ended. And the next one is reset one, and the reset one is used by the processor to reset it, and it is control signal, and it is already in this instruction is used whenever the processor is ready to execute an instruction. And one is clock signal. It is organized by the timing and control, and it is AEN, address enable, and it enables the address of the timing and control. It is address STB, and is address 7, and it is a communication between the peripheral devices, and it is memory read operation. Whenever you want to read any instruction from the memory, it is used. It is memory write operation. Whenever you want to write any one from the memory, it is used. It is IOR. It is input output read. Whenever we want to perform an input output read from input output devices, it is used, and it is write. Whenever we want to write from any data from input output devices, it is used. And coming to priority encoder rotating priority logic, and it consists of DRQ, and it consists of four from DRQO to DRQO3, and the next one is DARs, and direct acknowledgement, and it consists of also 4, and DARCK3 from K3, and HLDA and HRD. And the coming to the buses, here the buses are IO buffer, and it is buff from DB0 to DB7, and the next is IO buffer. It is also bus from A0 to A3, and it acts as a slave. And coming to output buffer and command buffer, command from D0 to D1, and it is from A0 to A7, and here it has a master master. And these are the internal ones. From internal coming to here, it is a temporary word count. It stores the count of a temporary words in a register, and it is of 16 bit. and it is a temporary address register. It stores the temporary address of any instructions, and it is of 16 size. Read buffer, it is a base address, it is of 16. It stores the initial address of any initial address of instruction, and it is base address count, and it stores the count of the instructions which are stored. It is of 16. These both are of size of 16. And this is the current address. It stores the current address where the instruction has been executed at the current time, and it stores the current word count, and it stores the word count of the current instructions. And coming to the command register, it is also used. It is size of a 8-bit, and a mask register, it is size of 4-bit, and a request register is of 4-bit. These are all 8-bit, but it uses only 4-bit one. And it is mode, it is also 4 into 6. It is also used to know the mode of an instruction. It is status register. This is used to know the current status, so current which instruction is being executed by the processor is stored here. And it is a temporary register which shows the temporary address of any instruction. It is of 8-bit, and it is of an 8-bit also. And then this is about an architecture of 8237. Thank you.